Welcome to Samba Samba. Enjoy the video.
You begin by assembling the essential inputs and launching the first calculations. Input vehicle dry and propellant mass, specific impulse, thrust versus time, and expected altitude profile. Once done, pick a modeling approach, simple 1D mass flow for quick estimates or quasi-1D nozzle flow for stage-level accuracy, and set a time step small enough to capture thrust transients. Make sure to define boundary conditions like ambient pressure and nozzle exit temperature. Then run a baseline burn simulation to see initial delta V and acceleration profiles. Now you dive into the detailed execution. Calculate instantaneous thrust, mass flow, chamber pressure, and exhaust velocity to integrate delta V and acceleration across the burn. Then perform sensitivity sweeps, vary specific impulse, propellant mass, and thrust pulse timing to find critical drivers of performance. While iterating, include gravity and drag losses and adjust nozzle expansion ratio for expected altitude. Use transitional checks to validate energy and momentum budgets. If numerical instability appears, reduce time step and reevaluate convergence settings before proceeding. Finish by compiling time histories into concise metrics: total delta V, peak acceleration, burn duration, and propellant consumption. Next, cross-validate your outputs against analytic Tsiolkovsky estimates and any experimental or historical benchmarks to ensure plausibility. Once validated, prepare sensitivity charts and margin tables for decision-making. If results deviate unexpectedly, check mass continuity, unit consistency, and time step convergence first. A common fix is correcting unit mismatches or tightening solver tolerances, then rerun the simulation and inspect residuals.
Thanks for watching. Consider subscribing if we helped you.